Alright, in this video, I want to talk about video streaming. Now, why do I want to talk about video streaming specifically? Well, because if you are working in an edtech company, or let's say if you've worked on any company or basically any website that hosts a large number of videos, then learning video streaming is going to help you a lot. Because it's always good to know the behind the scenes behind how the video is being sent from the server to the client and how it's being processed and all that. And also during interviews with edtech companies and so on, I have been asked questions about video streaming, which I think is a pretty interesting concept that you should know. Whether you're front end, back end or full stack, this is asked you regardless if you, let's say, interview for big companies or basically senior roles. So in general, this is a concept you should know about, not just for interviews, but because it's pretty interesting. So I'll give you a very brief or high level overview, or I'll also dive in a little more deeper into things. And overall, you'll get to learn a lot about video streaming in general. And also this is important because in websites like Netflix, YouTube, Hotstar, they utilize video streaming very heavily. So knowing how this works behind the scenes is going to be a very essential aspect for you as an engineer. So let's not waste any more time. First, I want to talk about why do we need video streaming? Alright, so what is the importance of this? What is the importance of video streaming? Well, think about this. So let's say here we have the client and here we have the server. So basically, the client is obviously you, or basically the browser. So the client is where we see the video, or basically where we upload the video files, and the server is basically where we process the video. So now just imagine if I go to YouTube and I try to watch a video, and let's assume or let's say that YouTube isn't performing video streaming. So if YouTube doesn't perform video streaming, there's a huge drawback. What will happen is, let's say I click on a video, then the server will directly try to send the video to the client. So if YouTube doesn't utilize video streaming, then the server is going to directly try to send the requested video to the client. And what's the drawback with this? The drawback in this is that we know that video files are big in sizes, right? So let's say if it's 200 MB or 500 MB and so on. So if the server directly tries to send the video to the client, then the client will have to wait for the video to get completely downloaded in the client. So until the video hasn't been completely downloaded, the client won't be able to view the video. And depending on your internet connection, it could take you some time for the video to get downloaded, right? So even if it takes 10 seconds, let's say, to download a 100 MB video, or if the video is a longer one and it takes you 10 to 20 minutes, then it's such a bad experience, right? That the server has sent the video, but the client is waiting for the entire video to be downloaded before they can view the video. Now that's not at all a good experience. And also the bandwidth is going to be so high because at one go, the server has sent, let's say, a 500 MB video file to the client, and the client is waiting for the entire video to be downloaded before it can even watch the first minute or the first second. So that is a very slow experience for the client. And that is exactly where video streaming comes into the picture. So video streaming, what it allows us to do is, you must have noticed in YouTube when we watch a video, sometimes we get a buffered screen. For example, sometimes the video just loads, we watch some part of it, and then sometimes it pauses, or basically it keeps loading or buffering like this, right? Well, that's because YouTube does not directly send the entire video file to the client. The YouTube streams parts of the video to the client, which gets loaded progressively, and as the client keeps on watching the video, more parts of the video get sent from the server to the client progressively. Alright, so what is the benefit of this? Well, right away you can tell that the first benefit would be that the client won't have to anymore wait for the entire video to download. Alright, if we stream the video to client, then the client only has to wait for that specific small video chunk to get downloaded. Let's say that chunk could be the first 10 seconds. So the client will only have to wait for the first 10 seconds, alright, and not the entire video. So this means this is going to allow the client to watch the video right away. It doesn't have to wait anymore for the entire video to download. And that right away is such a great user experience, right? So that is one huge benefit of video streaming, that it's going to be very fast on the client side. And that is essentially why people do video streaming. So for example, let's say Netflix doesn't want to give you the option to download the video, because then what's going to be the point of Netflix if you just directly download the video? Because if you own the video, then using a streaming service like Netflix is going to be redundant. Why would you ever come back to Netflix again after you download the video? So that's why they let you download the video either in their platform, but not to your particular device. And Netflix also streams videos to the client because movies can be, let's say, 2-3 hours long, and in the client side we don't want to wait that long for the entire video to download. It sends you small chunks of the video, and let's say what happens is, let's say it sends you the first 10 second, and then let's say you have almost watched 5 seconds, then maybe YouTube or Netflix has this algorithm, or they put this check where if the user has watched the first 5 seconds, then send the data for the next 10 seconds. All right, in that way, as you keep progressing towards, more and more video keeps getting progressively loaded or added to the client itself. All right, and another benefit to this is, another benefit of video streaming is, instead of sending the entire video to the client, we are sending only small chunks, right? So let's say if the user watches 1 minute of your video and decides to click away or switch to another video, or maybe just close the browser entirely. So the benefit of this is that the server hasn't sent the entire video to the client, right? So we are basically saving the bandwidth. So if the user skips after 1 minute, then maybe the server must have sent the video chunks up until 1 minute 30 seconds or 1 minute 15 seconds or so on. So this means it did not send the entire video length. It only sent the video chunks for maybe a little extra or a little more than 1 minute. So if the user decides to click away, the server didn't have to send the entire data of the video to the client, which ultimately, in a situation where if the user clicks away from the video in between, then the server doesn't have to send the entire video to the client, but only progressive chunks. Then in that case, the website, which is basically YouTube or Netflix, saves on cost because the bandwidth turns out to be less, right? Because in progressive video streaming, we are not directly sending the entire video to the client. So let's say if a video was 500 MB and the user, let's say, watches only 1 minute, then the server must have sent, let's say, 1 minute 30 seconds of data, which let's assume is nothing but 100 MB. Then after the user goes away or clicks away after 1 minute, there is still 400 MB that the server hasn't sent. So basically YouTube ends up saving 400 MB of bandwidth data, which is pretty cool, which is really amazing and really cost saving for a platform like YouTube, which hosts so many videos, right? Because as you know, when the server sends data to the client, when the server shows any data to the client, then each resource, each image, video, text, they all constitute some amount of data. And based on that data that is being transferred from the server to the client, which is YouTube, gets charged, right? Gets charged by their hosting service. So the lesser data YouTube can send, or the more YouTube can optimize the way they send the data to the client, the more cost they can save for their particular video or their particular website. All right. So that's why progressive video streaming or video streaming is so essential, because it helps save costs, improves user experience by so much, and so on. All right. Now let's just try to dive in a little behind how video streaming works, let's say behind the scenes. All right. So let's say I'll first remove all this on the screen. So let's now try to understand how video streaming works behind the scenes. All right. So I'll go back to my client and server architecture. So let's say I write client over here, and here I write server. All right. So when the user uploads a file, let's say on YouTube, when the user uploads a file, so what happens is the client obviously sends that file to the server, right? The video file goes to the server. That's pretty obvious. Now, what happens after that? Well, when the client uploads a video file, we know that video files can be large in size. When the video file is uploaded to the client and it goes to the server, the job of the server is to take that video file and store it somewhere, right? So that other people can see it later on, or we can see our video later on when we land on YouTube again. But the server, before it stores the video file somewhere, it does something. It basically passes the video file through an encoder. All right. So the video file comes to the server. Now the server passes the video file through an encoder. So let's say I write an encoder over here. Now you might be wondering what an encoder is. Don't worry, I'll tell you that soon. All right. So the file over here, video file, goes through an encoder. All right. Now what is an encoder? Well, let me go down a bit. So an encoder is nothing but something that compresses or decompresses the video. All right. So in this case, when the video file comes from the client to the server, the encoder makes sure to compress the video file, because the video in general is very huge in size. So we want to compress it as much as possible while maintaining the best quality we can. And then we want the server to store it somewhere else. All right. Basically in some cloud storage, or maybe in your own in-house server storage option. So encoder is nothing but something that compresses or decompresses your file. In this case, it's going to compress your video file. All right. So when the video file comes to the server, it goes through the encoder in the server, and the encoder compresses this video file. All right. So there is this compression that goes on. Compression. All right. So the encoder compresses the video file, and then after the compression is complete, the final video file that we get is what's stored somewhere else from the server. All right, basically the server takes that compressed video file and then it stores it somewhere else. All right, so after the compression is complete, let's say this goes somewhere and gets stored, let's say in some storage place. This can be anything like cloud or something like that. All right, so now there's one more thing you need to know. We don't just directly compress the video file and store it somewhere in the cloud or wherever you wanted to store it. The compression over here that occurs through the encoder, that compression is done in a different way. So basically, when the encoder compresses the video file, it makes sure to compress it in a particular format. So basically, when it compresses the video file, it creates multiple files. All right, so basically, let's say file 1, file 2, file 3. Now, what are these multiple files? Well, the encoder makes sure to create different versions of this video file before it stores it in the cloud. And what do I mean by different versions of this video file? Well, that means when the video passes through the encoder and it compresses it, it creates different versions of it, and each of those versions resemble the resolution and the bit rate of the particular video file. Now, what do I mean by that? So when the encoder compresses the video file, it does not just want to store one video file in the final storage. All right, it wants to create multiple different files from it so that it can store its different specific resolutions. By resolution, I mean, let's say it makes one file where the video file stored is of high quality, let's say 1080p, or in fact, instead of 1080p, let's just call it high. All right, let's say in the first file over here, the encoder, when it compresses the video file, it stores the video in this file, which stores the highest quality video of this video file. Then at the same time, it creates another file where it decides, let's also store a medium quality version of this same file. So it also stores a medium quality version of that same file. At the same time, it also stores a low quality version of that same file. So for this one particular video file, the encoder decides to store a high, medium, and low quality, or basically tries to convert it into different resolution and bit rates and store it in separate files. And what do I mean by bit rates? Well, bit rate is nothing but the amount of data that is being transferred from the server to the client per second. All right, so let me just go down over here a bit. All right, so when I'm talking about bit rate, so basically when I say that in these individual files, the encoder is going to store the information of the result and the bit rate in each of these individual files. So for the file that contains the high quality video file, it's going to have a different resolution and bit rate compared to the medium and low files. Similarly, medium is also going to have a specific resolution and bit rate, which is different from the low quality video file over here. All right. And why is bitrate required? Because as I said, bitrate is nothing but the amount of video data that is transferred from the server to the client per second. So in the high quality file, we store a larger bitrate compared to medium and low. And in medium, we store a larger bitrate compared to low. Now you can guess by this right away that a higher bitrate, let's say a higher bitrate means nothing but a better quality, or basically a higher quality. Now why is that? So doesn't this statement actually make sense? Higher bitrate equals to better quality. Well, because if the server sends more bitrate or higher bitrate per second to the client, that means we are sending more data of that particular video chunk per second to the client, which means per second the video data that is being streamed to the client has more data in it or more content in it, which means it has less loss. And if it has less loss and more data in it, then it means that we are able to comprehend, or we are able to see the video quality in a much better way, right? Because it has more data in it. However, let's say if our internet connection was poor, then in that case, the server would send lower bitrate or lesser bitrate to the client per second, which means it would send less video data to the client per second. And if less video data is being sent for the same number of seconds, so let's say the server is progressively streaming a video to the client, and let's say it's trying to send 2-second chunks of video. Let's say for 2 seconds, if the internet connection is bad, then the server is going to have a lower bitrate because it's not going to be able to send more data per second because the internet connection is slow. So it's going to be able to send less data per second. So less bitrate. So for the same 2-second video, it's going to send less data for that 2 seconds. And if it sends less data for that same 2 seconds, then doesn't it mean there is some loss in the video data? And what happens when there is loss? When there's loss, then the final video that the client receives, it's obviously a little bit hazy or unclear. And that is what happens when you switch to low or medium quality on YouTube, basically 360p or 480p and so on. You notice that even for the same video duration or the same video clip you're watching in 480p, it has bad quality compared to 1080p. Because in 480p, the server for the same number of seconds, it sends less video data. So it has lesser bitrate. And because of that, there is some loss in the quality of the video, due to which the video appears to be very unclear. Alright, so higher bitrate means better quality. But obviously we should not have the bitrate to be very high, because in that case, we are going to be sending a very huge amount of data per second. That could lead to a higher bandwidth, and that could incur a lot of cost to the client or to the website, which is, let's say, YouTube or Netflix. Alright, so we should ensure that the bitrate should not become too high as well. But a higher bitrate is congruent to better quality. Alright, so basically now you know that the encoder, when it receives the video file from the client, it compresses it, and before storing it to the cloud or somewhere, during the compression process, it creates different files of that same video file, and in those files, it stores the information for the resolution and bitrate that it needs to send when the client tries to retrieve that file again. So in each of these files, we are going to have nothing but resolution and bitrate settings. Alright, so just know that these three files will store this same video file, but this file over here will store the highest resolution and highest bitrate. This file will store the medium resolution and medium bitrate, and this file will store the lowest resolution and lowest bitrate. Alright, and each of these individual files will contain this information, the resolution and bitrate it needs to send. And then once the video file has been broken down into these three files, then after that, after the entire compression process is over by the encoder, then the encoder finally stores it somewhere in the cloud, or basically in your own traditional server itself, based on however you have set your preferences as. And in the cloud, there are obviously many different options like AWS and many more cloud providers. Alright, so that's up to your own preference. Now this is what happens generally in video streaming. Alright, now you might be wondering why we are converting it to high, medium and low during the compression process by the encoder. Well, I already did explain that to you, but basically whatever I explained you, it has a term to it. So when it compresses the video file and stores it in different types of files, and this doesn't just have to be high, medium, low, there can be more files. There can be 1080p, 720p, 480p, 360p, 144p and so much more. So this entire process where it breaks down those files like this, and then it stores it like this, so that when the client later on requests to the server to watch the video, then the server makes sure that it sends either the high, medium or low file based on the internet connectivity. This entire process is known as nothing but dynamic adaptive streaming over HTTP. Now, isn't that pretty obvious? Dynamic adaptive streaming. So let me first write that down. Let's say I'll just write it over here. So this is nothing but dynamic adaptive streaming over HTTP. Alright, and this term over here, in short, this is known as dash. So DASH, right? Dash. And this term actually makes a lot of sense, right? Dynamic adaptive streaming over HTTP, because what this basically means is, let me actually go up, right? So what this dynamic adaptive streaming over HTTP means is, when the client finally requests for that video file, let's say the user wants to view that video, then based on your internet connectivity, your server is going to send the video file from the server to the client based on the internet connectivity. And let's say if your internet connection is good, then it's going to send the high quality video file, or basically it's going to send the chunks of video data from the high quality video file. So let's say for the first 10-20 seconds, or let's say for the first 20 seconds, the internet connection is great. So the server sends chunks of video from the high quality file, and the client is able to view a very high quality video. But then let's say after 20 seconds, the internet connectivity or the network conditions degrade a little bit. Like let's say the internet connection becomes a little slow. Then after 20 seconds, what the server is going to do, the server is going to see that the network connectivity is a bit slow now. So it's going to go to the medium file, and then it's going to take out, let's say, the next chunk of data, let's say for the next 20 seconds of the video, and it's going to send that chunk to the client, right? So in that case, the client is going to get a medium quality file for the next 20 seconds of the video. So haven't you noticed when you watch a YouTube video that when the quality is set to auto, sometimes the quality is great, but then it again becomes a little blurry, and then it again becomes picture perfect and so on. Well, this is how it happens through dynamic adaptive streaming over HTTP, which is based on your network condition. The server sends the video chunks from the high, medium or low files based on whether the internet connectivity is slow or fast. Alright, and that is the reason why the encoder, while compressing the video file, creates these different files. And these files are actually called manifest files. Alright, but just to boil it down, I had to show it to you like this. But these files are called manifest files. The encoder creates separate manifest files which contains the same video but with different resolution and bitrate settings, which in simpler terms means high, medium, low quality, and so on. Alright, so this is pretty much all about video streaming, but there's one more thing left. So if you remember, I said, right, that the server compresses the video file when it receives the video file from the client. So when the client requests the video back, when they want to, let's say, view the video, so in that case, the server sends the video chunks to the client, right? So because the video file in the server was compressed, so the server sends the compressed video files to the client. So the client needs to make sure that it decompresses those video files before the user can view it. Alright, so when we send video chunks to the client, so basically the client media player or the media player in the browser, it uses something called codecs, which is nothing but the same as you can consider it as the encoder. The codec also performs the compression and decompression tasks. Alright, so just know in simple terms that a codec, it simply compresses and decompresses digital media files such as audio and video. So the media file has that codec, which when it receives the compressed video file from the server, it decompresses it. And after the decompression is done, we get the full video file, and then it's visible to the client, and the client can watch the video with the best quality depending on its network connection. Alright, so now you know what codecs do as well, and basically you must have heard some sort of codecs. So for video codecs, we have something like H.264, or there's even H.265 and so on. So these are the video codecs. If you open any video editing platform and then you try to export the video, then it asks you that should we do it in H.264 or so on. So that is what decompresses the video file. Alright, and similarly for audio files also we have MP3 codec and so on. And just remember that whatever I said for the video, that the same thing is done for the audio as well. So basically when the client first of all uploads the video to the server takes this video file, passes it through the encoder compresses it, which converts it into different manifest files, and then it finally stores it in the cloud, right? Now it does that for the video file, and it does the same thing for the audio files as well. So remember that it stores the video and audio files both like that. Alright, and now apart from that, in this video we did talk about Dash a lot, right? Dynamic adaptive streaming over HTTP. Now this is nothing but a streaming protocol, and another popular protocol you must have heard of is nothing but HLS. Alright, you must have heard about HLS as well. HLS is nothing but HTTP live streaming. And the HLS streaming protocol also follows a very similar approach to the Dash streaming protocol. And the Dash streaming protocol is what we discussed in this video, everything that's happening here. HLS also does something very similar to Dash, but HLS is more used during, obviously as the name suggests, for live streaming, while Dash is more used for pre-recorded videos, such as in YouTube or Netflix. Alright? So that is all I can tell you now for video streaming. So behind the scenes, these are all the things that happen, and it's pretty interesting to dive deep and see how these things occur. You can open the network and see all of that, and or you can also check in Google for how the encoder creates different manifest files and it stores the resolution, bitrate, video URLs and all that. So behind the scenes, this is how it occurs. In my different interviews or while working in edtech platforms or basically video courses platforms, these streaming protocols are used, and this is how it works behind the scenes. You can obviously go more deeper into this, but that's for another video because that will make the video length extremely long. But if you're asked this question in an interview to explain how video streaming works, you can very well explain all of this, all of that you learned over here. So the key takeaways here would be nothing but, let's say you can just talk about how the client and server communication happens, and then you can talk about nothing but the encoder. Alright, and then you can talk about manifest files, how the encoder converts it into different manifest files, and then you can talk about bitrate. So basically bitrate, resolution, bitrate and resolution, and you can talk about storage because then finally it stores the video rate. And then you can also, let me go down here, you can also explain them a little bit about Dash, which is the adaptive streaming protocol, and you can also tell them a bit about HLS. And then you can also talk a little bit about the codec, which is how in the client side it decompresses the video. So all in all, these are all the essential concepts that are asked, and it's also something you should know if you're working in a video streaming like platform. If I missed out on any points over here, you can just go up here and check it out. Alright, so that's all for the video. If you found it insightful, drop a like and don't forget to subscribe for more.